So let's first talk about link selection. Now, there's some new stuff here. Um, when you click on the custom box, each overlay has, its bonding settings. So each overlay has a different custom box that you can click on and modify. Uh, the link selection mechanism, you have two different modes, waterfall and balanced. And when you click on waterfall, you'll notice there's a little drop down there. You've got several different options. These options are these are part of what goes into that rebalancing portion. So when we're in high quality mode, for instance, or if we want to do a high quality style, um, use this link first until it's full, and then use the next best one and the next best one and so on. What determines next best, or what determines the order that we rank the links in? And that's what this drop down is giving you here. It's saying there's a couple of them. Overall quality, it's like Moss, but it doesn't include jitter, and it has a heavier bias toward the impact of loss. It's like Moss for data is kind of one way of thinking about it. Like Moss is more of a voice thing. This is the internal metric, or the overall quality. It's also called auto in other places in the local breakout. The overall quality score is our own internal thing, and it's what we use for high quality mode. So high quality uses overall quality as its determination of what's the best quality link. It uses overall quality. But let's say I didn't like that. Let's say I don't agree with your combination of latency and loss and this number you spit out. I just want you to pick the lowest latency link, period. Well, then we would set that waterfall selection thing there to latency. Or maybe I want to prefer the link that has the absolute lowest loss. I select loss or jitter and so on. The one that's new, and again, I think will be useful to some people that just maybe they don't trust SD-WAN. They're like, I don't trust you guys to make a decision as to who's got the best loss, or I don't trust your latency scores, or whatever it is whatever thing they might say. They can just pick link order, and link order, then it will take the actual order that these boxes are configured in and sort them that way. So the order matters finally. In this one place. It also matters in the local breakout. The new local breakout stuff has a link order mechanism as well. So it's kind of like fixed order. Link order, fixed order, they're kind of the same thing. One thing to note is that the waterfall action, it's 5 milliseconds. So if you have 5 milliseconds of wait time, then it will trigger the waterfall action. It'll tell the Silver Peak to hunt for the next link, the next best link in the order. So the wait time is important. I want to talk about that real quick with you guys, because a lot of people don't know where this is, or they don't even know what it is. So wait time is found on the screen you see here. Go to monitoring, and then QoS trends, and then do like 4 hour, and then pick the wait time toggle toward the top of the page banner. And that will show you how long during that period packets had to sit in the traffic class queue before they could be sent. And so this is like if I've got a ton of real-time traffic, and I also have a ton of best effort traffic. The expectation is that the real-time traffic should be allowed to go, but the best effort traffic should have to wait, or it should be queued up before it can be transmitted. And if packets are waiting to be transmitted because there's congestion or there's something else that's using up the available bandwidth, that will manifest as wait time in this chart. Very useful place to go troubleshoot, especially if you're troubleshooting charts that show plateaus. If you see big flat spots in your charts, the customers are complaining about throughput. Taking a look at wait time can be a good place to go. And wait time, of course, also serves as one of the mechanisms that triggers the Silver Peak to waterfall to the next best link.